In this how-to video, we're talking about how to find slope. You can jump to each slide depending on which type of slope you need to find. Press play when you get to each slide. So in this problem, we're finding slope when given two ordered pairs, and the formula that we're going to use for slope is going to be m equals, because m is the formula for slope, y2 minus y1 over x2 minus x1. So before I start, I actually just want to label my ordered pairs. So ordered pairs always go x comma y. So I can label them each like that. But then since the 5, negative 8 ordered pair comes first, I could label that x1, y1, and then 10, 12, x2, y2. So now I'm just going to plug into my slope formula. So it's going to say m equals 12 minus negative 8. So notice that this minus sign right here is this minus sign. You just drop it down. y1 is a negative number, so you're minusing a negative, over 10 minus 5. And so now that I have that, I'm just going to make it a little bit smaller, and I'm going to actually do out the math. So I'm going to get m equals, if I make this plus positive, m equals 20 over 5, which would give me a final answer of 4 over 1, or just 4 would be fine. Now what that means is, since slope is the ratio of vertical change to horizontal change, that means that this line, for every one step on the x-axis, it's changing by 4 on the y-axis. So if you connect that, you could actually kind of see that it would be a decent sized point. So it would be going over 1, 1, 2, 3, 4 up. And then if I connect those two, you have a slope that looks like that. So in these examples, we're going to see how to find slope when you're using a graph. So you could, if you wanted to, make the two ordered pairs and then use the y2 minus y1 formula. But instead, I'm going to use the rise over run formula, which is actually the same as delta y over delta x, because delta, remember, means change in. So you'd just be finding the change in y over the change in x. So to do that, I'm going to actually zoom in on my graph. I'm going to count the vertical and the horizontal distance. That's how you find your rise and run. So the rise would be 1, 2, and the run would be 1, 2, 3, 4. So the slope of this line would be 2/4, but then that would reduce to 1/2. So 1/2 would be your slope for that line. On this line over here, again, we'll find the vertical distance, or the rise. So 1, 2, 3, 4. Sorry, 1, 2, 3, 4. Yep, over 2. So this would be 4 over 2, which would reduce to 2. But then on this type of a line, you have to be careful that you put in the negative sign, because since the line is going down from left to right, the slope on this line is negative. So negative 2. So these lines are just here to show a variety of slopes. So this slope would be negative, and it all has to do with reading it left to right. So as you move this way, the line is going down. So negative slope, positive slope. Again, this is as you're reading left to right, the line is generally tending to go upward. This is a slope of 0. And if you were actually going to do rise over run, or y2 minus y1, either way, the 0 would end up on the top, and you'd end up with some number on the bottom. It doesn't even matter what the number is, because 0 divided by anything equals 0. And you can actually type that into a calculator, and it will tell you 0. This slope right here is undefined. And part of the reason is for that. For these three slopes right here, this is as x increases, because on a coordinate plane, when you move left to right, x is increasing. So this is as x increases, y decreases. As x increases, y increases. And as x increases, y stays the same. For this one right here, you cannot define it in terms of as x increases, because x is not increasing. It's not moving left to right. And in the fraction, if you do y2 minus y1 over x2 minus x1, or rise over run, the 0 would end up on the bottom. And if you actually type that into a calculator, it would tell you that you have an error. My hint for that is if the 0 is under the line, it's undefined. And I just kind of trailed off there, but that really goes with this guy over here. Oops. So rate of change is really simple. It's exactly like slope, so you can find it using rise over run or y2 minus y1, or in this case I'm going to use delta y over delta x. The thing that really matters is the units, because rate of change is really slope in the real world, so you need to know exactly what those units are. And then the next thing I have to decide is what's x and what's y, because they don't say that. They say hours and dollars. So to do that, the first thing I'm going to say is that y depends on x. And that's because x is the independent variable, y is the dependent variable. And in this problem, the amount of money that you make would depend on the number of hours that you work. So you can see that y is really money and x is really hours. So I'm going to find the change in money, or the change in y. So from here to here it's 20, 20, 20, 20. So since it's constant, I only have to do it really once. So delta y would be $20 over the change in hours, which each time the hours is changing by 4. And notice that I'm keeping those units, dollars and hours, as part of my answer. And now I'm also going to make it into a unit rate, so I'm going to divide top and bottom by 4, and I'm going to get $5 per hour. So the rate of change in this problem is $5 per hour. Always change your answer to a unit rate, meaning you need to have a denominator of 1. Always include those units as part of your answer.